Okay. So today we'll create subroutines. So what is a subroutine? Subroutine is a modularization technique. Subroutines
That
are
is
local to program,
the
same
program
program.
itself.
We cannot reuse same subroutine in other programs like include programs. Yesterday we have created include programs, right? So the same include program can be reused in any other include program or any other executable programs. Okay. So whenever you need any same kind of functionality, instead of creating it from the beginning, you can just reuse that in the, and also like if you keep code in the include program, what will happen? Like it will provide better readability, right? Instead of writing all thousands of lines of code in the same program line by line, if you modularize it using include programs, so it will provide better readability, right? You're going to divide that entire program into different functionalities, right? So it will provide reusability option and it will provide better readability, right? So what is the syntax to call the subroutine?
perform
Perform,
and perform.
subroutine name. If you need to pass any importing parameters like input parameters, right, you can use using value 1 or input 1, input 2, right? And if you want to return any value from the subroutine, you can use changing output value. This is optional. Using and changing are optional. If you don't want to pass any inputs, right? If you don't want to pass any inputs, you can simply use perform and the perform name to call the subroutine. Even though it is old concept, subroutines are old concept. Like there are a lot of programs, or if you are working in the support projects, the code is already implemented in subroutines. So to work on those, you need to understand subroutines. In sales and distribution module also, so we can create enhancements using subroutines, like we have user exits concept. So there also we need to understand the subroutines, like how to use the subroutines. And this is to call the subroutine. Where we are going to implement the code, to implement the code we have a subroutine definition that should be after this perform statement. Form, subroutine name. Again, if you have any inputs using, we generally use type here, input 1, type, for example, Matner, type maktx. Form, end form. In between form and end form, we should write our functionality. Just like how you implemented the code in include programs, you need to write code in between form and end form. How to call the subroutine? Using perform statement. Okay. There is one important note where we need to keep this form and end form after all the executable statements of the program. Okay. So because after form and end form, no statements will execute. Okay. It won't allow to execute any statements after form and end form. For example, you keep form and end form here, and if you are writing some select statement here, select star from, it won't accept, it won't execute this select statement. The program is not going to execute this select statement. So whatever the executable statements you should keep before form and end form, like this. Okay. So preferably at the end of the program, form and end form should be end of the program. After form and end form, it won't allow any executable statements. Okay. So let's create one program using subroutines. So this is the program which we modularized yesterday using include programs, right? Instead of writing all the code in the same program, we modularize. So each part of the program, different functionality of the program into one include program, so that we can reuse these include programs anywhere. So can we create subroutines in include programs? Yes, we can create subroutines in executable programs as well as include programs. Okay. Only thing you need to remember, keep in mind is you should not keep form and end form in the here, like form and end form should be at the end of the program. Okay. First, let me create a simple program. Okay, this is not required. Okay, let me create some simple functionality. Maybe to add two numbers, I'll define two parameters. I'm using one variable for the output. I'll create one subroutine to perform this calculation, right? To perform this calculation. So how to define the subroutine? We have two ways. First we can define form and end form, and then we call the subroutine. The other way is first call the subroutine and define the subroutine using the same statement. What is the perform add numbers? This is the subroutine name. This is the subroutine name. Provide any meaningful name. Provide any meaningful name, right? And if you want to pass input parameters, pass like this using p underscore val1, p underscore val2, and changing. So it will return the output. It will return the output. Changing lv output. Capture the output into lv output variable. We have already defined one variable. Okay. So now perform add number does not exist. So this subroutine is not available. We need to create it. How to create it? Just double click on it. So it is asking where we need to keep this form and end form. Is it in a main program or use a separate include program to keep all the form and end form? So I am selecting main program, same program. So where it is added, where the form and end form is added, after at the end of the program, right? By default it is added at the end. Okay, because after the form and end form no statements are allowed, no executable statements are allowed. You can only keep form and end form, multiple forms and end forms. Okay. Now this is not using any type, right? This is not using any type. So you can provide, if you want to provide specific type, you can pass like this: type I, type I. Then now what is the name, parameter name we can use here? Do we need to use these parameters, or which one we need to use? This one. Whatever the parameters, it is defined in the subroutine level. So we are going to use these parameters for our calculation inside the subroutine. You can change the names even. You can change these names. If you want, you can change these names. Equal to, check. Now return the output here. So print LV output. So that subroutine should return the output to LV output. Activate. Execute the program. Let me keep a breakpoint here at the perform. 20. Execute. We are passing the data here. Two parameters, two inputs and one output. Okay. Provide one space to provide multiple inputs. F5 will go inside the subroutine. So these are the subroutine parameters. Changing like output is returned to LV output, print it. Okay. Now if you want to call subroutine multiple times, you can simply call it wherever required, right? You can call it multiple times like this. Okay. If you want to change the parameters next time, you can change it like this. So instead of value 1, I'll pass LV output here. I'll print the next subroutine output. Here also I'll add output. Next subroutine output. Okay. So if I press F6, it will complete the execution in single step, right? If I press F5, it will go inside the subroutine. Pressing F6. So output is 30 now. Now we are passing that 30 as a input to the next subroutine call, right? Now it is 50. Again we are calling the same subroutine and passing the updated value as input, right? So we can call subroutine like this with different inputs. This is optional. Using or changing is optional. If you don't want to pass any inputs, you can simply call perform and the subroutine name. You can simply use this, and you don't need using and changing in the definition as well. Okay, we don't want to pass any inputs. I'm defining one variable here. I'm defining one variable here. Can you tell me, can I use this variable? Can I use this variable here out of the subroutine, for example, here? Can I can I use that variable here? I've defined the variable inside the subroutine. Can I use that variable in the main program?
Yes, sir.
No. So this is local to the subroutine. This is local to the subroutine. The data and memory is local to this subroutine. You cannot use this variable outside of the subroutine. Okay. If you define any data declarations inside the subroutine, you can only use those data declarations inside the subroutine only. They are available only within the subroutine, right? So these are called local variables. Since it's a variable, we are calling it as local variable. If it is work area, local internal table. Whatever the data declarations you defined in the within the subroutine, they are local to the same subroutine. You cannot refer them in the other main program. Sorry, not or in any other subroutine, right? These are local to the same subroutine. You cannot refer to these data objects in any other subroutine or in the main program. Okay. So it is saying LV data is unknown, right? Because this LV data is local to the subroutine. Only you can refer this within the subroutine. Okay. What about this LV output? What type of variable it is? LV output. We defined here, right? In the top of the program. LV underscore output we defined here on top of the program. This is global memory. So it provides global memory. This variable you can use in any subroutine, include programs, whatever you are using further, right? So the memory of this LV output is available for all the programs or statements which you are writing here, because we defined here globally here in the top of the program. Okay,
Yes,
clear?
sir.
So even you can use this LV underscore output here in the subroutine also. I'm just using it, so no errors. You can access this global data declarations in subroutines in include programs. Okay, memory is global. You can use it in any object. Okay, when you define these objects, data objects in the top declaration, like starting of the program. This is very important. You should remember, right? Sometimes we need to define data objects locally, right? Then you cannot access them in out of the that object, like in out of the subroutine. Okay. So if you think like this variable is not required for any other object, this memory is not required for any other functionality within the program, you can keep it as local. Okay. There is also very important even in the quality check standpoint. Some variables you need to define local and some variable you need to define global. Okay. And you need to follow some naming convention. Usually in projects, what we follow for global variables and we use GV for variables, GS for work area, GT for internal tables, global internal tables. Okay, LS, LT, LV for local variables. Okay, we need to follow some naming convention to understand which one is global and which one is local. Is everyone clear?
Sir,
Yes.
can we give the right statement inside the form and end form, sir?
Yes, we can.
So will it
Yeah.
make any difference, sir? Like
No, no, no,
keeping it outside?
no, no difference. Only thing we can you don't need to call it multiple times. See, actually, you can simply.
Oh, okay. Okay.
But here you're not passing the data to LV output, right? You're not. You need to print this. and you don't need this changing parameter now,
Okay.
right? Because we
Yes,
are
sir.
printing in the subroutine itself. You don't need to return any value and remove it here as well. Okay.
So the variables are different now, sir.
Yeah, yeah, sorry.
In top, you have given variable,
Ah,
different variable.
that's right. Okay, okay. We can simply use LV output here. We'll define that variable here, or maybe we can directly use LV output instead of parameter LV output. We can directly pass that because since it's a global variable, LV output is a global variable, right? Because we
Yes, sir.
defined on the top of the program. So memory is accessible for any object. I'm going to use same here. Okay. So
Yes, sir.
just observe the syntax, how to define a subroutine and how to call the subroutine. So if you try to write any executable statements after this, for example, write, it won't allow. Okay. So you should keep all the executable statements before form and end form. Let me create one more subroutine. Double click. So do you want to create this program in a new include program or in the main program? So usually what we can do, right? We can keep all these forms and end forms in one separate include program. Provide the name of that include program underscore sub. I'm creating one include program. Why? To keep all these forms and end forms. Continue. New entry. Created a subroutine, sorry, include program, right? It's created an include program and kept the form and end form inside the include program. Activate this include program and go back to the main program. So where it kept the include program? At the end, right? Now I'll remove the form and end form from here. Double click and I'll keep the other form and end form also here, right? So that you don't need to keep form and end form in the main program. You can keep that in one subroutine, sorry, include program. Okay. You need to keep this include program at the end. You try to add this include program in between these executable statements, will throw error. Statement is not accessible. Why? Because in this include program, you kept a form and end form, right? So if you add this include program here, whatever the statements available in this include program will be part of this main program, right? Keep the include program at the end because it contains subroutine declarations or subroutine definitions. Okay. 01 clear on subroutines.
Yes, sir. Sir, can we use this
Yes,
include
sir.
program in any other program, sir?
Oh yeah. So you can use this include program in other programs. So
Okay.
we cannot call subroutines in any other programs, right?
Yes,
Directly.
sir.
So we have other way around. We keep
Include.
those subroutines inside the include program and use that include program in other programs, right?
Yes, sir.
Simply create one program. So how can we reuse subroutines in other programs? Keep that in a include program and use that include program in the other programs. I'm just using the events, even though I'm not using all of them, so that you can remember the sequence, because this is the common interview question. So I'll keep the include program here at the end and perform. What is a, can we use any name here? Can we use any name here for subroutine name? You cannot use whatever the name you provided in the definition. You can only use that name. Okay. And do we have importing input parameters for this? Yes, we have two input parameters. So pass those two input parameters using 10. I'm just passing some hard coded values. You can also pass values like this, inputs like this. Okay.
Yes, sir.
LV output is unknown. I think we have defined like we are using LV underscore output right here. So
Yes, sir.
we need to define one global variable
Yes, sir.
here. Global variable, or if you defined it in within the subroutine, it should work. See, whatever the variables you are defining on top of the program right here, these are called global declarations. Try to use GV. Okay. GV for variable, GS for work area, and GT for internal table. Try to use that naming convention. Okay. Because in the most of the projects, they follow this naming convention, right? For global declarations. For local, LV, LS, LT. Okay.
Yes, sir.
So I'm using LV only for now because I'm using LV in the subroutine level. Activate, execute. So we got the output, right? So multiple times you can call this subroutine with different inputs. So we go for subroutines when we need to execute the same functionality multiple times within the same program. Okay. Or you can reuse the code whatever available in the subroutines by keeping those subroutines in one subroutine definitions in one include program. Okay, clear?
Yes, sir.
So I've just used this calculation here, but in general, you can write select statements, loop statements, read statements, anything inside the subroutine definition. Okay. You can write whatever the code we implemented in the main program, all those statements you can implement here to modularize it. Okay. Here, what is the difference between subroutines and include program? Include
Include program
programs are global,
is used include program is a global.
subroutines are local to the same program.
Local to the same program.
Include programs cannot
Yes.
accept any input. Subroutines can accept the input
Then I
and return the output.
with output.
Right? So whatever the data declarations like variables, work areas and internal tables you defined inside the subroutine are local to the same subroutine. You cannot use them in the other subroutine or in the main program. Okay. If you want to use any variable or work area globally, defined in the top of the program. Okay. Clear? Usually you can keep all the global declarations, right, in one include program, all global declarations and selection screen design, right, parameters and everything you can keep in one include program here, just like how we added it in the top. Instead of writing all those type structures, data declarations and everything in the program itself, create an include program and keep those all in one include program. Okay, for better readability, right? Okay, next we'll see function modules, the other modularization technique, that is function modules. So what is the transaction code to create the function modules? SC37. SC37 is the transaction code to create the function module. So how it is different from subroutines and include programs? Function modules are global objects. You can call function modules in any program, right? Unlike subroutines. Subroutines can be called only within the same program, right? But function module can be called in the any program. Function modules can accept the input and return the output, right? Function modules can accept the input and return the output. To create function modules, there is a prerequisite, that is function group. We need a function group to create the function modules. So let's see what is a function module and what is a function group.
One question.
Yeah,
So the subroutine and routine both are same, or is it different?
routine in the sense you are talking about requirement routines, what we use for output control. Yeah, usually, yeah, we refer that as routines.
Hello.
Can you hear me? Hello, can you hear me? Can you guys hear me?
So you're not audible, sir.
So function modules are used to modularize any functionality so that you can reuse the same functionality in different applications. The function modules are global.
The screen not shared, it seems.
Okay, let me share. So the function modules are global. Global means can call in any other program and can execute independently, right? Function modules can execute independently. Can we execute subroutines independently? No, we cannot execute. We can execute only through other program. When we keep the subroutines in program, the subroutines will execute along with the program execution. But function modules, we can execute function modules independently. Okay. So to create a function module, we have one prerequisite, that is function group. So what is a function group? So it is a container of related function modules, or we can group, we can group related function modules in one function group, related or relevant function modules into one function group. So whatever the function modules we are grouping in the function group will use all the global declarations of the function group. It will all the function modules, whatever the function modules you are going to group in a function group, or you are going to keep in a one function group, all those function modules will share common data of function group. Okay, common memory or common declarations of the function group. Is everyone clear? So function group we use to group relevant function modules, right? So what is the need of grouping these relevant function modules? To share common data and common data objects, right? So all the function modules which you are grouping in one function group will share the common memory. Okay. So what is the prerequisite to create function module? So we need to have a function group. You need to assign a function group for the function module. And there are, after creating the function modules, when you are creating the function module, after creating the function group, when you are trying to create the function modules, you can see different options to create the function module. There are three types of function modules. First one, normal or regular function module. Second one, RFC function module. Third one, update task function module. You can see three different types of function modules. It's a very important interview question about function group and types of function modules. So what are the three different types of function modules? Normal or regular function module, remote enabled, or I'll provide the complete definition. Remote enabled, remote enabled function module and update task function module. RFC means remote function call. Remote function call. RFC means remote function call. So what is regular function module? Can call only in the same SAP system. Only call within the same SAP system. What do you mean by system? SAP system. If you go to our SAP, we have two different servers, right? 2022 and 2021. If you are using normal function module that is created in 2022, you can use that function module only within the this 2022 server. Any program within the 2022 server. If you try to use 2021, it won't allow because you created that regular function module in 2022, right? So you can use that function module only within the same SAP system, right? What is the next function module we have? Remote enabled function module, RFC function module, can be called in other SAP systems. Can be called in other SAP systems also using RFC connection. We need to have a RFC connection to call the remote enabled function module in other SAP systems. Prerequisite is there is a RFC connection established between these two servers. For example, you created RFC function module in 2022. So you can call that 2020 in 2021 using that RFC destination. So why we use this RFC function modules? To access data of different SAP system. If you want to access data of different SAP system, you can use a RFC function module. Okay. Update task function modules executes after commit work. It executes after commit work. There is a certain functionality of using update function modules. Sometimes when we are updating multiple tables or when we are inserting data into multiple database tables. So what is our requirement? To create some sales order data in the relevant sales order tables, right? So for example, what are the sales order tables?
VBAK, VBAP.
VBAK, VBAP. VBAK is a header table and VBAP is the item level table. So we need to make sure when we are creating the data is created in all the tables like header data and item data created properly. For example, header data is successful and item data creation is not successful. Then what we should do? We should stop everything, right? We should not even create the header level data also, right? Because the item level data execution is unsuccessful, it is failed. So that we should stop everything. We should not create any data in any table, right? So to make sure that consistency, we use update task function modules. So once everything is successful, then we execute commit work. So after the commit work, whatever the functionality we implemented inside the update task function module will be executed. Okay. There is a concept of logical unit of work. We'll discuss that later. So three types of function modules: normal, RFC, and update task function modules. So depends on the requirement, we are going to choose a relevant type. Let's create a function module. What is the transaction code to create the function module?
SC37.
37. SC37 is the transaction code. Here provide the function module name. I'm creating a simple function module, add numbers, create what it is asking for, function group name.
Default group.
You can see this check mark symbol, right? That means it is a mandatory input, right? Without this, you cannot proceed further. So if you have any existing function group created, so you can use that function group, right? Let's assume we don't have any function group created. Now first let's create the function group. How to create the function group? Go to function groups and go to option, we have function group, create function group. You can also change and display the function group, create function group. Z demo underscore, use some FZ, okay. Provide the description,
Oh,
save it. Now your function group is created. What is your function group name? ZDemo FZ. Is that activated? Let's check, is it active or not. Go to function group, display function group, ZDemo underscore FZ, right? ZDemo underscore FZ. Continue. Is this active?
no, sir.
No, right? So we need to activate this function group. Before going to use this, we should make sure the function group is active. So there are two alternatives to activate the function group. One is go to the main program, master program here. Go to the master program here. What you can see inside this function group?
Include
Include
program.
programs. It will automatically generate include programs for each function module. This is for global declarations, top declarations, right? Top include, and there is one more include. This top is for global declarations. Whatever the global declarations available in the top include can be shared by all the function modules which we are going to assign for this function group. Okay, we need to make sure even this include programs also active. Okay, first activate one by one. This is active. Activate the top include. Maybe I'll activate all together. This one. What are the objects available for this? There are a lot of inactive objects. Now it is active. Okay. So activate the master program. Now it is active. Go back to the function group. Now it is active. Okay. Or what is the other alternative to activate the function group? Go to SC80, SC80. We call this as object navigator. Here you can access any object, any SAP object. Select function groups. Select function group here. Provide the function group name. Enter, press enter. Provide the function group and press enter. Simply right click on this and activate. Okay. So it will activate the function group. This is the other alternative. So you can use whatever easy option for you. Create the function module. Provide the function group name. You can use F4 to search for existing function group, right? Save. Function module name is function module name is reserved for SAP. Yes, continue. Save the function module. Now let's go to function group and check. I'll open SC37 in a new session. Go to function groups, display group, ZMOFC. Go to the master program. If you observe, in this include program, it created another include program, right? Automatically. What is this for? What is this include for? You can see this comment, the function module name. So it created one separate include for the function module what we created here, right? It is automatically generated one include program in the main program. Now observe it carefully. So this is the function module attributes. What you can find in the attributes? Processing type. Processing type means type of the function module. What type of function module it is? Is it a regular function module, remote enabled function module, or update function module? What type of function module you are creating? Depends on the requirement, you need to select it. So what is the difference? Regular function module will execute within the same system. RFC function module will execute in, can be called in other SAP systems also. Update function module, it will trigger only after commit work statement. For now we are creating regular function module. Yes, yes. What is your question? Okay, no. Okay. Next, check import. Check import tab. What is import tab? Here you pass the inputs for the function module. Whatever the inputs you want to pass, you need to pass it in the import parameter. It will accept the input. It will accept the input. For example, follow some naming convention here. Follow some naming convention. For example, I underscore value 1. Select the type and associated type. You can provide the data element, right, or any generic types like I. Okay. Define one more parameter. Two. So import parameters are used to pass the inputs. How to return the output? Using export. Using export. For example, e underscore output type I. So import is to pass the input and export is to return the output. What is this changing? Changing is combination of both import and export. You can pass one value and update that value and return the output using changing parameter. Okay. Changing is combination of both import and export. You can pass one value and you can update that value and return it again. Tables. Tables parameter is used to pass the internal table data as input or return internal table data as output. That is tables parameter. You can pass the internal table data as input or return the internal table data as output. It is obsolete. Actually, it is outdated. Tables parameter is outdated. We have alternatives for that. Okay. Is everyone clear? Import, export, changing, and tables. Exceptions. In exceptions, we can raise the errors. We can raise the errors within the function modules. We'll see that in the next session. For now, we'll just create the basic function module. So we have importing parameter and exporting parameter. Let's use some calculation on top of this importing and exporting parameter. E underscore output equal to I underscore value 1 plus I underscore value 2. Check the function module. No syntax errors. Activate the function module. So we are using these two importing parameters and returning the value to exporting parameter e underscore output. You can see this is the exporting parameter, right? Now our function module is ready. So we say function module can be executed independently, right? So here you can use this option test or execute to test the function module. Provide value 1, value 2, execute, it will return the output. Okay, is everyone clear?
Yes, sir.
Now, do we need to use function modules like this executing here? Is that what we created for these function modules? No, right? So to modularize the program or code, so we need to call these function modules in our program. How to call the function module is inside the program? Let me create one program. FM means function module. Create executable. I'll use these parameters and global declaration in this new program as well. Startup selection. So how to call the function module in the program? Go to pattern. You can see this option pattern. Go to pattern. Select the call function option. Here in place of call function, provide the function module name and call it. So you need to make sure like you need to place cursor in a proper position before calling the function module. So it is automatically generated few declarations. I'm removing this. Now, how to pass the values to the function module? Here, what are these parameters? Importing parameters, right? Import parameters, right? We defined in the function module level. But here you can see them as a export. Whatever the parameters we defined in the function module as export, you can see them as import here. Enable this, uncomment this, pass the parameters. Parameter 1, parameter 2, and return the output to LV. Take one variable to return the output. Okay. So very important thing you need to remember is whatever the parameters are variables, you can also pass variables or hard coded values to this input 1 and input 2. You need to make sure both are referring to the same type. Both are referring to the same type. What is the type of p underscore val 1? Integer, right? Type I. What is the type of this function module input parameter? Type I. Both are same, right?
Yes, sir.
So we can pass the parameter to this function module import parameter, right? So if you pass a different type, it will give runtime exceptions. Okay, you need to make sure whatever the function module import and export parameter types and the passing variables and parameters in the calling program are referring to the same types. Okay. So you can call this function module in any program. You can even repeatedly call the same function module multiple times. Let's execute. 10, 20, execute. So if you press F5, it will take in the controller will go inside the function module. If you press F6, it will execute the function module in a single step. Okay, press F5, it will go inside the function module, and from the function module, if you want to jump to the main program, what you need to press? F7.
F7.
If you press F7, it will jump to the main program without debugging further. If you press F8, it will complete function module execution and main program execution also. Okay. So if you press F7, it will just complete the current function module execution and go back to the main program. Okay. If you don't want to debug the function module and complete the execution in single step, what you need to press?
F6.
F6. It will complete the execution in single step. Okay. This is how we need to call the function module.